Consider a square ABCD with a side length equal to 1. Next, we'll draw a 90-degree circular arc whose center is at A and whose endpoints will go from B to D. We'll draw another 90-degree circular arc, except this time we'll center it at B and have its endpoints go from A to C. The question is, what's the area of the goblet-shaped region in red? Pause the video and see if you can solve this tricky geometry problem. The first thing we'll do is draw in a few auxiliary lines. Let's call the intersection of the two arcs point G. We'll draw our first line, EF, through G and parallel to DC, creating rectangle CDEF. Next, we'll draw a line connecting point A to point G and another connecting point B to point G. Notice that lines AG and BG are both the radius of their respective arcs and therefore both have lengths equal to 1. And since AB is the side of the square, which is also equal to 1, that means triangle ABG is equilateral. We're now going to draw in a final auxiliary line. And this line will be a perpendicular bisector drawn from arc AG to line segment AG. This line is short and sneaky, but it's the key to the problem. And now the magic begins. Did you notice that that shape directly below that sneaky little line segment exactly matches the shape formed from EDG? And the shape above the line segment perfectly matches the shape formed by CFG. That means we just need to find the area of the 60-degree sector ABG and the area of the bottom rectangle CDEF. Before we do, we need to get a few more lengths. We already know that BG is equal to 1. Now if we focus on right triangle BGH, we can see that HB is 1/2. HG is the square root of 3 over 2, which we can easily get either using our 30-60-90 triangle relationship or the Pythagorean theorem. Finally, the height of our rectangle is FC. This is just line segment BC minus BF, or 1 minus root 3 over 2. Now we're ready to start calculating the areas. The 60-degree sector ABG has area equal to pi r squared over 6. Substituting a value of 1 for our radius, we get pi over 6. Next up is rectangle CDEF, whose area is DC times CF. Since the length of DC is 1, then the area is just equal to the width CF, which we already solved for. Now, let's add up the two regions. When we do, we arrive at our answer. And there you have it. The goblet-shaped region has an area exactly equal to pi over 6 plus 1 minus root 3 over 2. That comes out to approximately 0.658, or about 2/3 of the area of the square. I hope you enjoyed this video. If you did, please give it a like and consider subscribing. Also, I'd love to get your feedback in the comments. Thanks for watching and see you soon.